Hey, welcome to Next Gen Manufacturing Nexus. Today, we are diving into something that's absolutely critical on the factory floor: electrical safety. Look, the margin for error is basically zero, but one of the biggest dangers is often a simple, routine assumption that's just hiding in plain sight. So, let me just ask you a question, and honestly, this could save a life. In a world full of complex machinery, high voltage, all of it, what do you think is the single most dangerous assumption anyone can make before they start a job? Yup, that it's turned off. It sounds so simple, right? But that quiet little assumption is the root cause of countless near misses, serious injuries, and, even worse. It's a mental shortcut that can lead you straight into a disaster. Believing something is safe without actually verifying it? Well, that's a gamble you just can't afford to take. To really get a handle on the risk here, we've got to look at what happens when things go sideways. So let's break down a couple of real-world case studies where these simple assumptions led to some pretty devastating consequences. This isn't just theory. This stuff happens every day. Okay, so picture this, a seemingly simple job. Just taking out a fluorescent ceiling light. An electrician gets called in. He says he de-energizes the circuit and he's all set to get to work. And here's where the whole chain of failure really begins. The electrician trusted his tool. Why? Because he'd put fresh batteries in it that very morning. But here's the catch. His voltage probe didn't have an on light or any kind of self-test function, so he tests the circuit, sees nothing, and assumes it's safe. But what he got was a false negative. The circuit was live the entire time. And that right there, that just perfectly illustrates the core lesson. You absolutely cannot delegate this responsibility. It doesn't matter if you're the one doing the work or the one supervising it, you have to see that verification happen with your own eyes using equipment that you know for a fact is working. Trust, but verify, every single time. All right, let's move on to our next case, and you'll see how these things can build on each other. So here we've got an investigator who's working on a control panel after a boiler failed. The main power feed was shut off. Everyone was told the system was de-energized. So the inspector, he assumes, hey, main feed is off, all the danger's gone. But what he didn't account for was stored energy. As he's cutting a bundle of wires, his cutters short-circuit two leads that were connected to an external capacitor. The result? A loud pop and a big spark. The only thing that saved him from a serious shock was the insulated handles on his wire cutters. So the crucial point here is this. Off doesn't always mean de-energized. Things like capacitors, batteries, and other devices can hold a really dangerous charge long after you throw the main breaker. You have to think about all the potential energy sources before you can ever declare a piece of equipment safe. Seeing these failures makes it so clear that just reacting to accidents is not going to cut it. We have to build a system that's all about prevention, and that means we have to move away from making assumptions and toward a structured, proactive blueprint for safety. Real electrical safety, it's not a feeling, it's not a guess, it's a process. It's all about systematically identifying the hazards and then evaluating the likelihood and the severity of any potential harm. By breaking risk down into a kind of formula, we can turn this abstract danger into something you can actually measure and manage. And that management process, it looks something like this. First, you identify the specific hazards for whatever task is at hand. Then, you really think through what could possibly go wrong. Those are your failure modes. From there, you figure out how severe an injury could be. Then you determine how likely it is to happen. And finally, you define the overall risk level. This structured approach tells you exactly what controls you need to put in place to make the job safe. And the best safety programs, they build these controls around 4 foundational pillars. Think of these as the non-negotiable elements that turn safety from just a checklist into a real culture. So, pillar 1 is proactive maintenance. Safety begins long before anyone even picks up a tool. This means having accurate, single-line diagrams, basically your electrical roadmaps, and doing the studies to know what the potential fault current is. That's the maximum energy the system can unleash in a short circuit. Regular maintenance and audits, they prevent failures before they even have a chance to happen. Pillar 2, Lockout/Tagout, or LOTO. This is the physical procedure that makes sure a machine cannot be turned back on while someone is working on it. It's an absolute cornerstone of electrical safety, but believe me, it's also an area where a lot of programs really fall short. So let's look at the most common ways LOTO fails. It is not enough to just go out and buy a bunch of locks and tags. Every single machine needs its own specific lockout procedure, because a generic checklist can easily miss a secondary energy source, just like that capacitor in our case study. Training has to be hands-on, and the entire system needs to be audited regularly to make sure people are actually following the rules. All right, Pillar 3 is all about using and installing equipment correctly. Let's start with grounding. A super frequent and dangerous mistake is bonding the neutral and ground wires together in a subpanel. This should only ever happen once, right at the main service entrance. When you do it downstream, you create these parallel paths for current, which can energize metal frames and enclosures that should be totally safe to touch. The best practice is crystal clear. Keep them separate. Another common equipment mistake has to do with overcurrent protection. So think about a motor at startup. It takes this huge gulp of energy, what we call inrush current, just to get going. It's way more than it needs to just keep running. So if you size a breaker only for the running current, you're going to have constant nuisance tripping. Proper load calculations have to account for both that initial surge and the normal operating load. And that brings us to our fourth and final pillar, continuous training. Your people are your most important safety asset, period. They have to understand the specific hazards they're facing. The training needs to be tailored to their actual, real-world tasks, not some generic safety talk. And it needs reinforcement, with annual audits of individual practices and careful documentation of every single session. So, when you put it all together, what's the ultimate takeaway? Well, it brings us right back to where we started, doesn't it? The entire structure of a really strong safety program is built to fight that one single dangerous impulse, the assumption. So your mandate has to be to assume nothing. This right here is so critical to understand. A lot of people think safety is about wearing the right gloves or the right face shield, but PPE is what you rely on when every other system, your maintenance, your LOTO, your proper installation, and your training has already failed. It is the absolute last line of defense, not the first. True safety is engineered into the system long before you ever put on a glove. And that leaves us with this final question to think about for your own workplace. When you really look at your procedures, your training, and your culture, what do you see? Is it a documented, audited, living system designed to prevent harm? Or is it just a collection of habits, routines, and dangerous assumptions?